All right, let's now talk about Gaussian elimination. What is Gaussian elimination? Gaussian elimination is a robust algorithm for solving linear systems. Let me now define the words robust and algorithm. I'll start with algorithm. An algorithm is a recipe. It's a prescribed set of actions that will enable you to achieve a certain end. Now, those actions must be defined precisely enough that you can even teach a computer to carry them out. Or if you have a little brother or sister who can add and multiply, but may not even understand what it means to solve a linear system, that they would be able to carry out those actions. That's how precisely those actions need to be defined in order for a recipe to qualify as a mathematical algorithm. And those actions will include adding numbers to each other, or multiplying a number by 2, or switching numbers around, and so forth. So that's what an algorithm is. It's a prescribed set of actions that you can carry out quite blindly without understanding why they work or their purpose. Although I don't recommend that. I don't recommend not understanding why certain actions work or their purpose. But in any case, that's what an algorithm is. Now, robust. In mathematics, a technique is considered robust if it works under a wide variety of circumstances. Here's one small example. Think back to the simplest possible linear equation, ax equals b. What is its solution? Well, if you say that x equals b over a, that's pretty robust, but it's not ultimately robust because b over a doesn't work when a equals 0. In the case a equals 0, there's a lot more that you need to say in order for the algorithm to work in all circumstances. In other words, to be ultimately robust. So x equals b over a is pretty good, works almost all the time, but only almost all of the time, not actually all of the time. Well, from this point of view, Gaussian elimination is the most robust technique on the planet. It always works. It will always help you determine the general solution or to determine that a solution doesn't exist. So that's what Gaussian elimination is, a robust algorithm for solving linear systems. And now that we've discussed what Gaussian elimination is, let's talk about what Gaussian elimination isn't. And that will be the most important point. So far, we have solved every system simply by identifying the relationship of the vector on the right-hand side to the columns of the matrix and the relationships among the columns of the matrix. In other words, we've solved all of those linear systems by insight into those relationships. And you might be thinking that now that we're going to learn Gaussian elimination, an alternative technique for solving linear systems, and a robust one at that, we'll no longer have to worry about being clever or insightful or worrying about those relationships. Well, the opposite is true. Gaussian elimination is not an alternative approach to solving linear systems. Solving linear systems will forever be about the relationship of the vector on the right-hand side to the columns of the matrix and the relationships among the columns of the matrix. The purpose of Gaussian elimination is simply to help you see those relationships, to help you identify those relationships. Gaussian elimination works by introducing so many zeros into the matrix that relationships that may not have been obvious before now become obvious. So Gaussian elimination is not an alternative approach to linear systems. It's simply an enabler. It's a helper. It will help you identify the relationships of the right-hand side to the columns and among the columns that solving linear systems is all about and forever will be all about. Gaussian elimination is an exciting subject. Now, you may not think so at first. At first, you may think that it's just routine manipulation of numbers and that there's no beauty in it and that there are no aha moments, of which there were so many in the earlier topics. Now, to a certain extent, that's true, but only to a very limited extent. Number one, there's great beauty in robustness. Number two, there's a great deal of beauty in how well this approach works with an already established geometric perspective on linear systems. Furthermore, When we discuss matrix multiplication later on, we will revisit Gaussian elimination and we will reformulate it in the language of matrices and matrix multiplication. And that will introduce a whole lot of algebraic beauty to the topic of Gaussian elimination and actually to the entire subject of linear algebra. Finally, don't forget about the relationship of linear algebra to the computer. Linear algebra and its algorithms are perfect for computer implementation. And that's where much of the power, of the practical power of linear algebra comes from. Its relationship to the computer and code. Linear algebra has lots of algorithms that are perfect for computer implementation, and among those, Gaussian elimination is the flagship algorithm. Now in the computer, you will be able to solve not just 3 by 3 systems like this one with Gaussian elimination, but even 3 million by 3 million systems, and even larger systems. Now, interestingly, when Gaussian elimination is implemented on the computer, it loses some of its robustness for reasons that we won't go into right now. And the question of how to get that robustness back is interesting, exciting, and difficult in and of itself. And I don't believe that it has been completely answered to this day. So in summary, don't be detracted by the initial mundane feeling of Gaussian elimination. It is an exciting and beautiful topic, and you will grow to love it.